Hello and welcome to exercise session number 9. So today is going to consist of two parts. First, we'll have a look at the rule of L'Hopital, which is a very powerful rule to determine certain types of limits. Namely, it will help you calculate certain undefined limits. As per usual, you can find an overview of this in the theory overview. Afterwards, we're going to have a look at full function analysis, and this will also be the major part of the class. That being said, let's get started with the rule of L'Hopital and calculating a couple of limits. So for this, let's go to exercise series 1. And here we're going to start with the one I already talked about earlier in previous classes about the limit of x approaching 0 of the sine of x over x. Well, I told you up until this point, well, learn it by heart, remember that this limit is equal to 1. But the rule of L'Hopital, what does it tell us? Well, and I forgot my x over here, is sometimes, in certain cases, for certain undefined limits, basically the 0 over zeros and infinity over infinities, and, well, you will see that there are other types that you can convert back to these kind of types, which you can have a look at in the theory overview. We're going to make a couple of examples of those too. You can actually solve it by, instead of looking for the limit of this, you look for the limit of the derivative of the numerator over the derivative of the denominator. So in this case, well, this would be f of x, and in this case, this would be g of x. Okay, by using this, you'll see it's much easier now to prove that this is equal to 1 rather than using the sandwich rule, which you saw in the lecture previously until this point. So let's try this once. So first things first, we have to make sure that we are dealing with this type of undefined limit. Otherwise, we'll sometimes you have to convert it to this type, or sometimes you're not even dealing with an undefined, or sometimes, well, L'Hopital is maybe not the best way of going. So let's first check. So let's fill this in. We get sine of 0 over 0. So the limit of x going to 0, which gives us 0 over 0. Great. That means that we're dealing with one of those two types, meaning that you can take the derivative of both of them. So actually, you could say, well, this limit is going to be the same as finding the limit of the derivative of sine of x over the derivative of x, where x approaches 0. This would be equal to finding the limit of x going to 0 of the cosine of x over 1. Careful, this is not normally how you would take the derivative of a quotient, right? This is only because, well, we say it's the derivative of the numerator and the denominator separately, right? So in this case, we can just fill it in. And what do we get? We get that the limit of x approaching to 0 of cosine 0 over 1, which is, in other words, 1 over 1 or 1. So the rule of L'Hopital is very, very powerful in many cases. And in many cases, it makes a lot of things much, much easier to solve, especially things like this. But you always have to be careful with it, because what you don't want is for here in the denominator to end up with a 0, because then you're dividing by 0, and that's something, as you know, that causes all kinds of problems. So let's try, that being said, let's try a couple of other ones. Let's try exercise B. And in this case, we're calculating the limit of x approaching infinity. So it would be plus minus infinity of x times e to the power of negative x. Okay, so let's see what we're dealing with. So first case first, let us find the limit of, let me rewrite it a little bit. Let's say we'll first look for the limit of x approaching positive infinity. We still have to do the negative infinity, but we'll do that later. So let's fill that in. We find positive infinity times e to the power of, well, negative infinity, or if we rewrite this a bit, we get positive infinity times, well, in this case, 0, or you could say, let's move that to the numerator, and immediately you get e to the power of infinity, which would just be infinity over infinity. And as you know, this is undefined. Okay, and there's no clever trick that we can do like looking at the highest power of x, because well, x is part of the power. Okay, so that being said, let's rewrite this a little bit and see what we can do with it. Well, we could rewrite it as such. We could say, well, this is the same as solving the limit x approaching positive infinity of x over ex. And this already brings us a bit closer to what we have with L'Hopital, right? Because, as I said, well, you mainly are looking for infinities over infinities, or 0 over 0. And now we can just simply derive this. So let's try that once. So what do we get? Well, we get this is equal to 1 over e to the power of x by deriving this. So I'll write LH, that means L'Hopital. Let me not forget my limit here, x approaching positive infinity. Okay, let's fill that in for now. And what do we get? Well, we get that this is the limit of x approaching positive infinity over 1 over infinity. And as we all know, 1 divided by a very large positive number, you get that that's equal to 0. The same for a very large negative number as well. Okay, so in this case, L'Hopital was very handy. Let's have a look at the limit approaching x to negative infinity. And again, first things first, check this. Check whether it's necessary. So what do you get? You get negative infinity times e to the power of minus infinity. Or in other words, what do you get? You get negative infinity times positive infinity, which in this case does not yield a problem, because negative infinity times positive infinity is defined, which just gives us negative infinity. Okay, so far for B. Then we're going to make 2 more exercises. We're going to make C and D still here in class. So we'll do exercise C, and here we say that the limit x approaches infinity, and what do we get? We get ln x over x to the power of alpha. Okay, then what can we do to this? Well, let's first check what we're dealing with. So first things first, if we fill this in, we get infinity over infinity. So that means we can just clearly apply L'Hopital. So we'll apply L'Hopital, we'll take the derivative of both numerator and denominator, and what do we get? We get 1 over x over alpha, which, because it's just a number, times x to the power of alpha minus 1. Okay, and we're interested in finding the limit of that of x approaching, and I'm sorry, I forgot to write it here, positive infinity. Okay, so now you say, well, nothing really changed here, but it did. We just have to, well, massage this a little bit so that it turns out to something we can solve. Well, we could rewrite this over here a little bit differently. We could say, well, this is the same as writing x to the power of negative 1 over alpha times x to the power of alpha times x to the power of negative 1. I just broke them up in parts, right? And then now we calculate the limit of x approaching positive infinity. So in this case, well, what can we do? Well, we cancel out x to the power of negative 1 and x to the power of negative 1. We can cancel them out. And we get that we're finding the limit of x approaching positive infinity of 1 over alpha times x to the power of alpha, which in this case would just be 1 over a very large positive number, which is equal to 0. Okay, then let's try one more together. And here we get, we'll do exercise E. So here we get the limit of x approaching 0 of x ln x and the x squared. Okay, so with this thing here, well, you could immediately say, well, we have this ln here, we can drop the 2 to the front. Well, you can do that, but it's not really necessary, but of course you can always simplify it. Okay, so what do we have here? Well, we have here, if we insert a 0, we get 0 times, well, ln approaching 0. Well, what do we get? We get negative infinity, which is not defined. And this is a problem because, well, this is not one of those two forms. But if you look at the theory overview, it means that we can convert it in such a way that we do end up with such a form. So how would we do that? Well, we can rewrite it a little bit and we can say, well, this is exactly the same as saying ln x squared over 1 over x, right? Where the limit goes from x to 0. And in this case, well, what do you end up with? You end here up with something going to negative infinity, and here you end up with something going to either positive or negative infinity, but it goes to infinity as well, depending on how you approach it. So again, you have an infinity here. Okay, so once we have this, it means we can now apply the rule of L'Hopital. We can say, okay, we'll do the rule of L'Hopital, and what do we get? Well, we get that we are finding the limit of x approaching 0 of 1 over x squared, which is just the derivative of ln x squared, times 2x, remember the chain rule, over minus 1 over x squared. Okay, now we have that. Well, we can rewrite it a little bit. So basically what we have over here, we get 2 over x divided by minus 1 over x squared, finding the limit of that where x approaches 0. Let me rewrite it a little bit so it's a bit clearer. X approaches 0. So this, bringing this up, so what do you get? You get that this is the limit of x approaching 0 of 2 over x times minus x squared over 1. Rewriting it still a little bit, we get that this is the limit of x approaching 0 of minus x, sorry, not minus x minus 2x. In this case, what can we do? Well, I'll still write a 1. Maybe it's clearer here if I show what I did instead of immediately going like that. So basically I found this, just multiplying these and say, well, we can scratch out the x's and we just end up with minus 2x. We fill in the x approaching 0, so that means that this limit approaches 0. Okay, so here you can see, well, when you're dealing with these kind of things, you can always rewrite it. You can always see what you need to do. But don't forget, first things first, what you always need to do is to check what kind of undefined limit are we dealing with, and are we dealing with an undefined limit. So first things first, really check what this is, these things are. So this is what I have to tell you about the rule of L'Hopital. I'm gonna, as per usual, recommend a couple of exercises for home. The exercises you can make are D, H, J, and K. Okay, in the next video we're going to start doing full function analysis. This is going to be the bulk of the exercises. So have a look at this and then join me for full function analysis. Okay, good luck, see you there.